I am the son of mathematicians. My mother and father were part of the team that programmed the world's first commercial stored program computer, the Manchester University Mark I, which was sold by Ferranti Limited in the early 1950s. They were full of excitement over the idea that, in principle, a person can program a computer to do almost anything. They also knew, however, that computers were good at logical organizing and processing, but not random associations. A computer typically keeps information in rigid hierarchies and matrices, whereas the human mind has this special ability to link random bits of data. One day, when I came home from high school, I found my father working on a speech for Basil de Ferranti. He was reading books on the brain, looking for clues about how to make a computer intuitive, able to complete connections as the brain did. We discussed the point. Then my father went on to his speech and I went on to my homework. But the idea stayed with me that computers could become much more powerful if they could be programmed to link otherwise unconnected information. The challenge stayed on in my mind throughout my studies at the Queen's College at Oxford University, where I graduated in 1976 with a degree in physics. It remained in the background when I built my own computer with an early microprocessor, an old television, and a soldering iron, as well as during the few years I spent as a software engineer with Plessey Telecommunications and with DG Nash Limited. Then, in 1980, I took a brief software consulting job with CERN, the famous European Particle Physics Laboratory in Geneva. That's where I wrote Enquire, my first web-like program. I wrote it in my spare time and for my personal use, and for no loftier reason than to help me remember the connections among the various people, computers, and projects at the lab. Still, the larger vision had taken firm root in my consciousness. Suppose all the information stored on computers everywhere were linked, I thought. Suppose I could program my computer to create a space in which anything could be linked to anything. All the bits of information in every computer at CERN and on the planet would be available to me and to everyone else. There would be a single global information space. Once a bit of information in that space was labeled with an address, I could tell my computer to get it. By being able to reference anything with equal ease, a computer could represent associations between things that might seem unrelated, but somehow did in fact share a relationship. A web of information would form. Unbeknownst to me at that early stage in my thinking, several people had hit upon similar concepts, which were never implemented. Ted Nelson, a sort of professional visionary and a wonderful person, wrote in 1965 of literary machines, computers that would enable people to write and publish in a new non-linear format which he called hypertext. Hypertext was non-sequential text, in which a reader was not constrained to read in any particular order, but could follow links and delve into the original document from a short quotation. He had the dream of a utopian society where all information could be shared among people who communicated as equals. He struggled for years to find funding for his project, but success eluded him. Doug Engelbart, a researcher at Stanford University, demonstrated a collaborative workspace called NLS, short for Online System, in the 1960s. Doug's vision was for people to use hypertext as a tool for group work. In order to help himself steer his computer's cursor across the screen and select hypertext links, Doug invented a wooden block with sensors and a ball underneath and called it a mouse. In a now famous video, which I didn't see until 1994, Doug demonstrated using electronic mail and hypertext links with great agility, with his homemade mouse in his right hand and a 5-key piano chord keyboard in his left hand. The idea was that a person could interface with the machine in a very close, natural way. Unfortunately, Doug was also too far ahead of his time. The personal computer revolution, which would make Engelbart's mouse as familiar as a pencil, would not come along for another 15 years. With that revolution, the idea of hypertext would percolate into software design. Of course, the next great development in the quest for global connectivity was the Internet, a general communications infrastructure that links computers together, on top of which the web rides. I happened to come along at the right time, and with the right interest and inclination, after hypertext and the Internet had come of age. The task left me was to marry them together. The Research Center for Particle Physics, known as CERN, straddles the French-Swiss border near the city of Geneva. Nestled under the limestone escarpments of the Jura Mountains, 10 minutes from the ski slopes, with Lac Le Mans below and Mont Blanc above, it offered unique research opportunities, and the area offered a very pleasant place to live. Engineers and scientists arrived at CERN from all over the world to investigate the most fundamental properties of matter. Using enormous machines, they would accelerate tiny nuclear particles through a series of tubes that, although only a few inches wide, ran for several kilometers within a mammoth circular underground tunnel. Researchers would rev up the particles to extremely high energies, then allow them to collide. For an unimaginably brief instant, new particles might be made, then lost. The trick was to record the high-energy debris from the cataclysm as it careered off into one of 4 detectors inside the tunnel, each the size of a house, jammed full of electronics. Research on this scale is so expensive that it has to involve collaborations among many nations. Visiting scientists would run their experiments at CERN, then go back to their home institutions to study their data. So, though this was a central facility, CERN was really an extended community of people who had relatively little common authority. The scientists brought a wide variety of computers, software, and procedures with them, and although they came from different cultures and spoke different languages, they managed to find a way to work together because of their shared interest in particle physics and their desire to see a huge project succeed. In 1980, CERN was in the process of replacing the control system for 2 of the particle accelerators. The work was getting behind, and CERN needed help. I had, by chance, been consulting elsewhere in Switzerland when my friend and colleague Kevin Rogers came from England to suggest we apply. Upon our arrival to be interviewed, Kevin and I were given a tour, and soon found ourselves on a catwalk, looking out over what looked like a huge, chaotic factory floor. This vast experimental hall was filled with smaller experiments, obscured by the concrete block walls between them, hastily built to cut down radiation. Continuing along the catwalk, we came to the control room. Inside were racks and racks of hardware, with no lighting except for the glow of the many indicator lamps and dials. It was an electronic engineer's paradise, with columns of oscilloscopes and power supplies and sequencing equipment, most of it built especially for or by CERN. Kevin and I would join a team of people who would ultimately bring about the demise of that control room. Alas, the racks of glowing electronics would be slowly dismantled and replaced by a boring oval of computer consoles run by much more powerful software. The big challenge for contract programmers was to try to understand the systems, both human and computer, that ran this fantastic playground. Much of the crucial information existed only in people's heads. We learned the most in conversations at coffee tables strategically placed at the intersection of 2 corridors. I would be introduced to people plucked out of the flow of unknown faces, and I would have to remember who they were and which piece of equipment or software they had designed. The web-like structure of CERN made the job even harder. Of the 10,000 people in the CERN phone book, only 5,000 or so were at CERN at any given time, and only 3,000 or so were actually salaried staff. Many of the others had a desk, and visited from their home institutions only every now and again. I filled in the odd moments when I wasn't officially working by tinkering with my play program, the one I called Inquire. Once I had a rough version, I began to use it to keep track of who had written which program ran on which machine, who was part of which project. Informal discussions at CERN would invariably be accompanied by diagrams of circles and arrows scribbled on napkins and envelopes, because it was a natural way to show relationships between people and equipment. I wrote a 4-page manual for Inquire that talked about circles and arrows, and how useful it was to use their equivalent in a computer program. In Inquire, I could type in a page of information about a person, a device, or a program. Each page was a node in the program, a little like an index card. The only way to create a new node was to make a link from an old node. The links from and to a node would show up as a numbered list at the bottom of each page, much like the list of references at the end of an academic paper. The only way of finding information was browsing from the start page. The program was such that I could enter a piece of knowledge only if I linked it to an existing one. For every link, I had to describe what the relationship was. For example, if a page about Joe was linked to a page about a program, I had to state whether Joe made the program, used it, or whatever. Once told that Joe used a program, Inquire would also know, when displaying information about the program, that it was used by Joe. The links worked both ways. Inquire ran on the group's software development computer. It did not run across a network, and certainly not the Internet, which would not be used at CERN for years to come. Inquire had 2 types of links: an internal link from one page, or node as it was known, to another within the same file, and an external link that could jump between files. The distinction was critical. An internal link would appear on both nodes. An external link went in only one direction. This was important because if many people who were making such a link to one page could impose a return link, that one page would have thousands of links on it that the page's owner might not want to have to store. Furthermore, if an external link went in both directions, then changing both files would involve storing the same information in 2 places, which is almost always asking for trouble. The files would inevitably get out of step. Eventually, I compiled a database of people and a database of software modules, but then my consulting time was up. When I left CERN, I didn't take the Inquire source code with me. I gave the 8-inch floppy disk to a systems manager and explained that it was a program for keeping track of information. I said he was welcome to use it if he wanted. The few people who saw it thought it was a nice idea, but no one used it. Eventually, the disk was lost, and with it, the original Inquire. When I left CERN, I rejoined my former colleague John Poole. John had incorporated his Image Computer Systems, and Kevin and I returned to help. The business went well, but the technology we were working with was limited. In 1983, I needed a change from living in Britain, and remembered that CERN had a fellowship program. In the spring of 1983, I decided to apply, arriving eventually in September 1984. As a gift upon my departure from Image, John gave me a compact personal computer. It was touted as one of the first portable computers, but it looked more like a sewing machine, more luggable than portable. With my new PC and the freshness which comes with change, I wrote in my spare time another play program called Tangle. I wanted to continue to explore the ideas about connections that were evolving in my head. In an extreme view, the world can be seen as only connections, nothing else. We think of a dictionary as the repository of meaning, but it defines words